Hello everyone, it's Christina from the Glaser Tutoring Company, and today we got decimals. Ooh, we got decimals. They're part of a system of equations, and we have to solve them by the addition method. Spooky. Does anybody like decimals? Decimals or fractions? Which one is worse? I think, for me, I would probably have to say decimals. But to each his own. But either way, we're going to be solving the system of equations, and we're going to do it the addition way. Now, in this case, a system of equations is just basically when they list you at least two or more equations. So here's equation number 1, here's equation number 2, this is the system. Okay, now we have to basically solve this system. Well, what does that mean? Well, we have x values, we got y values, and these are linear lines because for my x values, it's just both of them raised to the first. And the same thing for the y's. They're both raised to the first. If you have x values raised to the first and y values raised to the first, they're linear, which means that they're straight lines. So maybe if one goes this way, like let's just say that this one goes this way, and the other one goes this way, the solution is where those two lines intersect. It's where they communicate with each other, right? It's the point in which they share. That's the solving. That's the solution. So you're solving for a point that they share. So if that's the case, we're looking for a x comma y. So we're just solving for x and we're solving for y. But the problem here is that usually with algebra, right, when it comes down to PEMDAS, comes down to algebra, you only can solve for one variable at a time. This isn't differential equations, right? This is Calc 3. So we need to basically eliminate one of our variables, whether we want to get rid of x or we want to get rid of y. And that's via addition. Now, there's 3 ways of solving system of equations. You're either going to substitute, you're either going to add, the addition route, or you're going to subtract, which is the elimination route. So if we're doing specifically addition here, we have to make one x value positive and the other x value negative. Now, it doesn't matter what values go in the front, they just have to be the same. So if it's 2x, the other one has to be negative 2x. If we're dealing with fractions and this is a fourth x, this one's got to be a negative fourth x. And if we're working with decimals, if this is 0.1, the other one's got to be negative 0.1. So we're either going to do that for the x, or you could do that for the y values as well. So it's your choice. Always pick the one that looks easiest for you. Now in this case, I have a negative x value, negative 0.1, and a 5. So one's already positive and one's already negative. That's good. And the other one, the y, we have one that's positive, one that's negative, 0.2, and 10. Now, think how we can get one to being the other, right? There's a couple of, couple of different ways that you could do this. But when in doubt, if you can't find the number that turns maybe one equation to the other, what you can do is you can multiply both equations by the other value. Now, maybe what I'll do is I'll use the 5 and the x with the 0.1 because these are smaller numbers to work with than this. But if you want to do the y's, you'll get the same solution at the end of the day. So what we're going to do is maybe this is equation 1 and this is equation 2. Now I have to come together to get 5 and negative 0.1 being the same number, but just one positive, one negative. So maybe what I'll do is I'll times this equation by 5, because that's the coefficient for the bottom, and I'll take equation 2 and times it by 0.1. Now, with the addition method, you do not multiply by negative, because you want to keep the negative for one and positive for the other. But if we are multiplying, the 5 has to be distributed to every equation, and the 0.1 has to be distributed to all the parts in the equation. So let's go for it. Let's do the top one, equation 1. So I'm going to be multiplying 5 times all these numbers. So 5 times a negative 0.1 1 is a negative 0.5x plus 5 times 2 is 10, but then you got to move that decimal over, so this is just 1. And if you want to put 1.0, that's fine. And then equals 5 times 6 is 30. You got to move the decimal over 1 to the left because there's a decimal here. So this would be 3.0 if we want to do it that way. Now let's just color this in. Blue for x. We got a red for y. And now let's do equation 2. 0.1 times 5 is 0.5x. So there's my positive and negative value. Let's keep going. 1, right? 1 times 10 is 10, but now there's a decimal, so you move it over to the left, so this would be minus 1y. And now we're going to equal it to 0.1 times 1. That would just be 0.1. Okay, now we're ready to add these two equations together. And let's see what we get. So this was the main point here, right? We have a negative 0.5 plus a 0.5. This whole thing's going to go bye-bye. But now, ooh, look at here. 1 minus 1. That's a big fat 0. And if that's the case, you lose your variable. We lost both of our variables here. There's nothing on the left side. Now, if we come over to the right side, 3 plus 0.1, that's 3.1. So the main thing here to notice is that you have lost all variables. So in this case, we have two different answers that can be a possibility now. Either we have parallel lines, right? Maybe this is a set of parallel lines. If it's a set of parallel lines, they will never intersect, and therefore they will never have a point where x marks the spot where they intersect. But if they are the same line, if here's my first line and the other one is the same line, they would have infinite number of solutions that they have in common because literally it's the same line. They just disguised it as two separate equations. But now the question is, which one? Well, it all comes down to whether this mathematical statement makes sense or not. 0 equals 3.1. Does this sentence make sense? Does this mathematical statement make sense? No, right? Because 0 is not 3.1 and 3.1 isn't 0. So this is a big fat X. And X translates to no, right? No solutions. So that means that these equations, if they have no solutions, they have no interactions, that means that these are part of parallel lines. Parallel lines. But just to put it into perspective, if you had either 0 equals 0 or 3.1 equals 3.1, then this sentence makes sense. And then, yes, they are the same line. So that would be infinite amount of solutions. But in this case, since this mathematical statement makes no sense, it has no solutions. And that's the answer to this set of systems of equations. There is absolutely no solutions here because these are parallel lines. And that is the end. What'd you think? I hope this helped. Let me know in the comments. I love reading your guys' comments. I try to get back to as many as I can. Thank you so much for being here, for learning with us, and for being part of the community. So, like the video, comment down below, tell your friends, tell your classmates. Also, I would like to give a huge shout out to Maricela. Thank you so much for being a member to the channel. Your support means a lot to my brother and me, and we're thrilled to have you be a part of this amazing community. Memberships are open on the channel, and if you want to become a member, just click that join button, which can be found below on any video if you're watching on your desktop, or it can be found on the overall channel page too. For all of you that want your name shown in the video, don't forget to choose the gold tier or higher. Thank you so much for considering, and have a great day. Talk to you in the next lesson. Bye-bye!